Hi everyone, you are watching Maths Tech 15. Today's topic is quadrilateral. In this video, we will see the definition and types of the quadrilateral and their applications and properties also. And this is the second video on basic mathematics series, and the first video I done on polygons. Still you didn't check means please go and check and subscribe the channel and share the videos also, and don't forget to like. Definition of quadrilateral. A quadrilateral is a polygon with 4 edges, 4 vertices and 4 angles. Quadrilateral means it's a polygon. Polygon means it's a two-dimensional figure. It is a two-dimensional figure and it should be a closed figure and it should be drawn with the straight lines. It will be drawn with the straight lines. That is called as a polygon. A polygon with the 4 edges. A polygon with the 4 edges, otherwise 4 sides, it is called as the quadrilateral. Quadrilateral means it should be a two-dimensional closed figure and drawn with the straight line. It is called as the quadrilateral with the 4 edges, 4 vertices here, 4 vertices and the 4 angles. Otherwise, you can also define as a quadrilateral is a two-dimensional closed polygon with the 4 sides and 4 vertices. Both the meaning is same only. Next is the sum of interior angle is 360 degree. The sum of interior angle of polygon is, what is the formula? That is n minus 2 into 180 degree. This is the formula for sum of interior angle of any polygon. Here the quadrilateral has the 4 sides here. So 4 minus 2 into 180 degree. 4 minus 2 means it is a 2 into 180 degree. That is the 360 degree. 360 degree. Okay. That meaning is this is the angle 1, angle 2, angle 3, angle 4. The sum of interior angle of any quadrilateral. It is here 360 degree. The sum of angle 1, angle 2, angle 3, that is 360 degree. And sum of exterior angle of the quadrilateral. Exterior angles. These are called as exterior angles. Okay. The sum of exterior angles is here. What is the sum of exterior angle? It is a 360 degree. Why? Because the sum of exterior angle of any polygon is 360 degree only. You can take pentagon, you can take hexagon, otherwise you can take even triangle also. The sum of exterior angle of any polygon is 360 degree. That's why the sum of exterior angle of quadrilateral is also 360 degree. Okay, you need to remember these two. And applications. Applications of the quadrilateral are here: architecture and construction, and land and property mapping, art and design, and transportation, sports and games also, and in engineering and mechanics also. Okay, these are the applications for the quadrilaterals. Now we will move to the area and perimeter of the quadrilateral. What is the meaning of area? Means this is the space between the 4 edges. This is the space. We are finding the area of this space. Okay, this is called as area. And perimeter means the sum of all the 4 sides. It is called as the perimeter. So what is the area of the quadrilateral? Means half d1 sum of h1 into h2. Sum of h1 into h2 means it is the heights of the h1 and h2 are the heights dropped down it. Dropped down it means it is a diagonal. See here I drawn the quadrilateral here. The vertices are a, b, c, d here, and the db is the diagonal. db is the diagonal, and ce is here. That is the height on the d1 here, diagonal, and the af is also height on the diagonal only. It is from the opposite vertices, from the C, and this diagonal has the two opposite vertices, C and A. From C we have to draw the perpendicular line, and from the A we have to draw one height. So here the area of the quadrilateral is 1 by 2 d1 into h1 plus h2. What is the perimeter? Means it is the sum of all the 4 sides here. Sum of all the 4 sides, AB plus BC plus CD plus AD. So here I given the name here ABCD. So A plus B plus C plus D, where ABCD are the sides of the quadrilateral. Next is types of quadrilateral. The quadrilateral you can divide into three categories. Here we can see in the quadrilateral two pairs of opposite sides, because the quadrilateral has the four sides na, we can say two pairs of opposite sides. If both the pair of opposite sides are parallel to each other, it comes in the parallelogram. If the both the pair of opposite sides are parallel to each other, it's a parallelogram. Only one pair is parallel, then it is called as the trapezium. Otherwise you can also call it as trapezoid also. And no opposite sides are parallel to each other, then it is comes the example for the quadrilateral is here kite. Okay, in the parallelogram again it will we can see rhombus, rectangle and the square. Rectangle means opposite sides are equal to each other and each angle measure is here 90 degree. And rhombus means all the four sides are equal to each other. Combining these two, it will form another one quadrilateral here, that is the square. Here all the sides are equal, taking from the rhombus, and each angle is here 90 degree. So the square will satisfy all the parallelogram properties, rhombus properties and rectangle properties also. Okay, trapezium, in that one we will also see another one, that is the isosceles trapezium. Isosceles trapezium means the non-parallel sides are equal to each other, it is a isosceles trapezium. Kite. So we will in detailed way we will see the properties of all these types of quadrilaterals. Okay, and this is the very important. Quadrilaterals, properties of quadrilaterals and the formulas. Formulas means area and measurements, and I gave examples where we will see these quadrilaterals. Okay, here first is parallelogram. The opposite sides are equal and parallel. How they are means the opposite sides are is here equal in measure and parallel to each other. Opposite angles are equal. Opposite angles, angle B equals to angle D, angle C equals to angle A. Opposite angles are equal. And adjacent angles are supplementary. Adjacent angles are supplementary. Why? Because they are parallel to each other. The opposite sides are parallel to each other. That's the reason the adjacent angles are supplementary. So angle A plus angle D equals to 180 degree. What is the supplementary means? The sum of two angle is 180 degree. Here angle A plus angle D, it is a 180 degree. And angle B plus angle C, these are adjacent angle, the sum is 180 degree. And angle A plus angle B, this is also 180 degree. And angle C plus angle D, that is also 180 degree. Now we will come to diagonal. How the diagonals are? The diagonals bisect each other. Bisect each other means they will divide, they will intersect, and they will divide into two equal halves. Here DB and AC are the two diagonals. Bisect means OD equals to OB. It's divides into two equal halves. OD equals to OB and OA equals to OC. Okay. A diagonal of a parallelogram divide it into two congruent triangles. So the diagonal of the parallelogram is here. You can take any, we will see the two diagonals in the quadrilateral. Okay. So if you the diagonal, what we will do means it will divide into parallelogram into two congruent triangles. It is the first triangle and it is the second triangle. It is a congruent to each other. Okay, this diagonal also. Divides the diagonal divides the parallelogram into two congruent triangles. Two congruent triangles. Congruent means the size and shape is all both is same. The symmetry. First we will see what is the meaning of line symmetry. Is a straight line that divides a shape into two equal parts, otherwise two congruent parts, where the parts are exactly reflects of the others. See here, if I take the rectangle, if I take the rectangle, because in the parallelogram there is no line of symmetry, that's the reason. The straight line divides the shape Here it's the otherwise diagram, otherwise you can take figure also. A line, it's a straight line divides the shape into two equal parts, other is two congruent. The congruent means all the sides are equal to each other and angles also, size and shape are both are equal, it's called as a congruent. Okay, it's divides into two congruent figures, that is called as the, that line is called as the line symmetry. Okay, it's a reflects reflections of their exactly same, this both are sames only. Okay, and next is rotational symmetry. What is the meaning of rotational symmetry means? It is a property of the shape or object where it looks the same after being rotated and around the center of the point by the certain angle. That meaning is, see here, if the parallelogram, if you are taken, if you rotate 90 degree, how it will looks here? It will somehow it will looks like this. Okay, after the 180 degree rotation, it will look same as it is its original figure. After 270 rotation, after 360 rotation, so after rotation of the figure, otherwise the object, it looks same as it is the original figure, then it is called as the, that is the rotational symmetry of order 1, order 2. Here the parallelogram you can see in the two times, you know, after rotating 180 and after rotating the 360 degree, it will looks like a same. So here the line of symmetry means it is a no line of symmetry, because no line makes the two symmetrical figures here. See here, if I take the, you can take any line. So see, it's both are not congruent to each other. Okay, you can take horizontal also, it's also not equal to each other. Okay, not congruent to each other. So there is no line of symmetry, and rotational symmetry of order is here 2. What is area of the parallelogram means? A equals to B into H. B means you have to take any side of the parallelogram, and the height means it should be a perpendicular line on that line. Okay, on that base. Okay, DE is the height here, then AB should be the base. If you take BC is the base means you should take the height is from the A only, that is AF. AF is the height. Okay, perimeter. Perimeter means it is the sum of all the four sides here. The two opposite sides are equal to each other, 2B plus 2A. 2 taken common, so 2 of B plus A. The example where we will see parallelogram is it's the floor tiles of the parallelogram shape. Okay, rectangle. The sides is here, opposite sides are equal and parallel. Opposite sides are here equal to each other and parallel to each other. And angles, all the angles are equal to 90 degree. All the angle A equals to 90 degree, angle D equals to 90 degree, angle C equals to 90 degree, and angle B equals to 90 degree. And how the diagonals are means, the diagonals are equal and bisect, they are equal, and that means BD equals to AC. The diagonals are equal and they bisect. Bisect means OD equals to OB, OC equals to OA, OD equals to OB, OA equals to OC. The diagonals of the rectangle divides it into two congruent triangles. The diagonals of the rectangle also divides into two congruent triangle. If you taken DB as a diagonal means it divides into two congruent triangles. So what is that one? DBC triangle and DAB triangle. Both are here congruent triangles. Symmetry is here. We can see two lines of symmetry. One is the vertical line and another one is the horizontal line. We can see the two line of symmetry. And what is the rotational symmetry means? Rotational symmetry is of order 2. One is from 180 degree rotation, one is from the 360 degree rotation. And area of the rectangle is here, A equals to length into breadth. Length and breadth. Perimeter means sum of all the four sides here, the 2L plus B, because opposite sides are equal here, L, 2L plus 2B. So 2 taken common. Where we can see the rectangle means screens and books, and even you can see this paper sheet also. This is also in a rectangle shape, and this scale also, this is also rectangle shape. Okay, next is square. In the square, all the sides are equal and opposite sides are parallel. All the sides are equal to each other. That meaning AB equals to BC, BC equals to CD, CD equals to AD. All the four sides are equal to each other and opposite sides are parallel to each other. AB is parallel to CD and BC is parallel to AD. Angles, all angles are equal to 90 degree. Each angle is here equal to 90 degree. If it is denoted by box shape means it's a, you need to understand it's a 90 degree only. How the diagonals are means diagonals are equal. Here also the diagonals are equal and bisect at right angle, and they will bisect here also. Bisect means they will divide into two equal halves and they are bisect at 90 degree. The angle of intersection is here 90 degree. Here also it's a one way it will come obtuse angle, one is the acute angle. It's exactly 90 degree. This is 90 degree, this is 90 degree, 90 degree. Diagonals bisect their interior angles. Diagonals are bisect their interior angle means it's divided into two equal halves. If it is suppose it's 90 degree na, so 45 degree, 45 degree. Divide the square into two congruent isosceles right angle triangle, and the diagonal will divide the here two. I will show you here. It's a square. The diagonal will divide here square into two isosceles right angle, because each angle is 90 degree only na. Isosceles right angle triangle. Isosceles right angle congruent triangles. Both are congruent to each other. Both the diagonals. And symmetry, here we can see four line of symmetry, that is vertical line, horizontal line, and according to the diagonal also. You can see here 1, 2, 3, 4, four line of symmetry. And rotational symmetry of order is here. Rotational symmetry also 4. In the 90 degree also you will get the same figure after rotating the 90 degree, 180 degree, 360 degree and 270 degree. If you rotate by 90 degree, you will get the same figure. You will get the, because here all the four sides are equal na, that's why after 180 degree rotation you will get the same. 270 also same, 360 also here. So that's the reason the rotational symmetry of order is here 4. The area is here, all the four sides are equal to each other, so area is S square. S into S, AB into BC. You can take any two sides. And if the diagonal, only diagonal is given means half of D square. Half of D square. Perimeter is sum of all the four sides here, all the four sides equal to each other. So perimeter equals to 4 into S. Examples here, chessboard and the square table top. If the table, it is the top is square means it is also example for the square. Okay. And here you need to remember here, the rectangle and square will satisfy all the properties of parallelogram, and in the rectangle each angle is here 90 degree, and the square is also each angle is here 90 degree. That's the reason the diagonals are equal. Only in a quadrilateral where we can see the diagonals are equal to each other means only in the rectangle and the square. Why? Because the each angle is here 90 degree. That's why you need to remember this one. The diagonals are equal in the rectangle also and diagonals are equal in square also. I will show you. See here, it's a rectangle. You can see it's visible also. It's a if I kept here straight, it's a 90 degree. It's 90 degree. It's a 90 degree. 90 degree means it should be a perpendicular line. Okay. It's a 90 degree. Then the diagonals are here equal to each other. We can see here diagonals. Here this is the one diagonal. This is the one diagonal. And this is the one diagonal. Diagonal means it is the line segment joining the opposite vertices, not adjacent vertices. This is called diagonals. So you can see the equal diagonals. If I bend like this, see here, the angles are changed. No angles are not equal to 90 degree. No, here angles are not equals to 90 degree. One is obtuse angle, one is acute angle. So here how the diagonals are, see this is the one diagonal and this is the another one diagonal. Are they equal? No, they are not equal. When the diagonals are equal means the quadrilateral angle, each angle is 90 degree, then the diagonals are equal. We can see in only rectangle and the square. Now see, whenever I bend this, I am bending more, this diagonal will becoming here from the angle, diagonal forming from the two acute angles. It's the diagonal is increasing in length, and diagonals made from the obtuse angle is the decreasing in the length. Okay, see here. If I make here straight, then the diagonals are equal. So that's the reason you remember here in the rectangle and the square, the diagonals are equal and they are bisect also. In all the parallelograms, the diagonals are bisect each other. And they made here two congruent triangles. Two congruent triangles. Here also two congruent triangles. Here also two congruent triangles. And here also two congruent triangles. Next is rhombus. Here all the sides are equal and opposite sides are parallel. Here also all the sides are equal to each other and opposite sides are parallel to each other. Angles, opposite angles are equal. Here not each angle are equal to 90 degree. In the each angles are equal to 90 degree means it will become square. Here only opposite angles are equal and the adjacent angles are supplementary. Why? Because the opposite sides are parallel to each other, then obviously adjacent angle sum is here supplementary 180 degree. That meaning angle A plus angle D, it's a 180 degree. Angle A plus angle B, it's also 180 degree. Angle B plus angle C, that is also 180 degree. Diagonals, the diagonals are bisect at right angle. See here, if all the sides are equal to each other, then the diagonals are bisect at right angle. We saw in the square also. In the square also, all the sides are equal to each other. So the diagonals are equal and bisect at right angle. So in the square and the rhombus, the diagonals are bisect at right angle. Okay. And here also diagonal divide the rhombus into two congruent isosceles triangle. Two congruent and isosceles. Why? Because all the sides are equal. Na? So here DB diagonal divides the rhombus into two congruent triangle, that is DCB triangle and DAB triangle. Here DA equals to AB, so it's a isosceles triangle. Here DC equals to CB, so it's a isosceles triangle. Symmetry, two line of symmetry we can see, and rotational symmetry of order 2. One is about 180 degree, another one is for 360 degree rotation. And area of the rhombus means A equals to 1 by 2 D1 into D2. D1 is the first diagonal, that is DB, and the D2 is the AC divided by 2. Perimeter means sum of all the four sides. Here all the four sides are equal to each other, so 4A. Each side is, if you take an A means it is the perimeter is here 4A. Examples, the diamond shaped tiles. Next is trapezium. Trapezium means here only one pair of opposite sides are parallel. Here only one pair, that is the AB is parallel to here CD. Then the another parallel sides we have to call as the base. Parallel sides of the trapezium we have to call as the base, and non-parallel sides we can call it as here legs. Usually we will call it as legs. Okay. The angles are here adjacent angles on a non-parallel sides are supplementary. So here AB is parallel to DC means the non-parallel adjacent sides, that is angles angle A plus angle D, it's a 180 degree. Angle B plus angle C, it's a 180 degree. Why? Because AB is parallel to DC. AB is parallel to DC. The co-interior angle of the parallel lines. That's the reason here adjacent angles of the non-parallel sides are supplementary. Supplementary means sum should be 180 degree. Symmetry means no line of symmetry will come and no rotational symmetry also. Diagonals, they are the intersect each other. That's it. What is the area of the trapezium is half HA plus B. Here A and B are the parallel sides. See AB and DC. They have given the name here. The parallel sides are AB. That's the reason A plus B. H means the distance between the two parallel sides. Height. Okay, parallel side. The distance between these two parallel sides. That is the height. It should be a perpendicular line. A equals to 1 by 2 H A plus B. Perimeter means the sum of all the four sides. A plus B plus C plus D. Examples, the lampshade base. Now we'll come to isosceles trapezium. Isosceles trapezium means it is a one pair of opposite sides are anyhow it's parallel and non-parallel sides are equal to each other. Non-parallel sides means legs. AD equals to BC. Then it is called as the isosceles trapezium. How the angles means the adjacent angles on non-parallel sides are supplementary. The non-parallel sides angles means angle A plus angle D equals to 180 degree, angle B plus angle C equals to 180 degree, and opposite angles also supplementary here. Opposite angles means angle C plus angle B. I will write here otherwise. Opposite angles means angle B plus angle C equals to 180 degree, and angle A plus angle C, it's also 180 degree. And the adjacent angles on the non-parallel sides means angle A plus angle D, and this is the angle B plus angle C. It's a 180 degree. Here the base angles are equal. See here the angle D equals to angle C. In the isosceles trapezium, we can see here the base angles are equal. Angle D equals to angle C, and their adjacent angles means D adjacent angle is A here and C adjacent angle B. They are also equal to each other. That meaning the upper side these two adjacent angles are equal to each other, and these two also equal to each other. Diagonals here, diagonals are equal. We can see diagonals are equal. That meaning is AC equals to BD. The diagonals are equal here. The diagonals divide the trapezium into two pair of congruent triangles. Here also the diagonals are divided into two pair of congruent triangles. How the symmetry will come? One line of symmetry and no rotational symmetry. If it is no rotational symmetry, then rotational symmetry of order 1. Okay? Don't get confused here. No rotational symmetry means order is 1. Why? Because all the diagrams are after rotating 360 degree, it will looks the same original figure only. 360 degree means it is a pen. If I rotate like this, it's no matching. It's also not matching. It's also not matching after 360 rotation. No, it's comes into same look. So that's the reason no rotational symmetry means order is 1. What is the area? Area of the isosceles trapezium here, A equals to 1 by 2 H A plus B. A and B are here bases, A parallel sides, AB plus DC. AB plus DC. AB is A and DC is B. Parallel sides. Height means that is the shortest distance, otherwise the height between the two parallel sides. Perimeter means sum of all the four sides here. Non-parallel sides are equal, so they have given the name here CC. So A plus B plus 2C, because if here in this case we have denoted with D because non-parallel sides are not equal to each other. Here the non-parallel sides are equal here. That's why 2C. Examples: the shape of roof and bridge design also. Next is kite. Here the sides means the two pair of adjacent sides are equal. The two pair of adjacent sides mean upper here, upper adjacent sides here. AB equals to BC. AB equals to BC and AD equals to DC. AD equals to DC. These adjacent sides are equal to each other. So AA, BB. Angles, one pair of opposite angles are equal. This angle A equals to angle C. These are the angles formed between the unequal sides, AB and AD and BC and CD. These two angles are equal. Angle A equals to angle C. Diagonals, the diagonals intersect at right angle. The diagonals are intersected here, right angle. Right angle means 90 degree. 90 degree, 90 degree, 90 degree, 90 degree. The longer diagonal bisects the shorter diagonal into two equal parts. The longer diagonal is here BD. It bisects the AC. That's the reason AO equals to OC. AO equals to OC. The longer diagonal divides the kite into two congruent triangles. The longer diagonal means BD. BD divides the kite into two congruent triangles. So you can see here ABD is congruent to BCD triangle. So BD diagonal divides the kite into two congruent triangles. How the symmetries are here? One line of symmetry you can see and no rotational symmetry. What is the area of kite here means 1 by 2 d1 into d2. d1 means diagonal 1, that is BD, and d2 means that is the AC. And perimeter means sum of all the four sides here. The adjacent sides are equal, a plus a to a, b plus b to b. So 2 taken commons means 2a plus b. Examples: the shape of kite used for the fly, and some decorative wall designs also you can see the kite. So hope all of you understood this one. And please, still you didn't subscribe the channel means please subscribe the channel and share the videos, and don't forget to like. Thank you.